Welcome to 9.9. So far, we have learned how to solve quadratic equations for their x-intercepts or solutions by graphing, looking at where the graph crosses the x-axis, by factoring, and by taking square roots as long as there's no b term. Today we're going to learn the final way to solve a quadratic equation, and it is by using the quadratic formula. This giant formula you will have memorized. Yep. And I have a few ways to help you memorize it. Before we get into memorizing it, let's take a look at a little bit about how the quadratic formula works.
Some simple calculations.
What's the quadratic formula?
Yeah, we'll get to that. But first, remove those shades and that baseball cap. The quadratic formula is the tool you use when those prime quadratics have you singing the blues. First, write your quadratic in standard form. Please be thorough. Ax squared plus bx plus c equals 0. Now, we're going to solve for x using our ABCs. So get those pencils in your hands and roll.
You take the square root of b squared minus 4ac. Then you add it and subtract it with the opposite of b. Take the values you get, divide them by 2a. Now you're solving the quadratic formulatic way.
Standard form?
No, it's not.
So take the number from the right side and drop it like it's hot. Now it's in standard form and it's easy to see. A is 1, B is -4, and C is 3. Now plug these values in the equation using order of operations. Please excuse my dear Aunt Sally, as was taught throughout the nation. And with careful calculations, X is 3 and 1.
The quadratic formula is a formula that gives you your x values of where your parabola crosses your x-axis and the values that will make your equation true. And it gives it to you in the form of a formula. No matter what, you can plug in A, B, and C to this formula to find your answers. For example, on this first example, A would equal 2, B would equal 6, and C would equal 1. Let's write out the formula and plug in these values.
Quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a.
X equals negative b is 6 plus or minus the square root of b squared, which is 6 squared minus 4a. C is 1 all over 2. A is 2. In case you haven't picked up on it yet, there is going to be a lot of singing this song in this notes video and in the next one for the sole purpose of helping you to remember this crazy formula. Now, when it comes to evaluating the formula, we're going to evaluate the part under the square root first. 6 squared is 36. -4 times 2 times 1 is -8. Keep that under the square root. Next, take 36 minus 8, which would be 28, and put that under the square root, bringing everything else down. At this point, we will break our answer into two pieces to get two solutions for our x-intercepts. The first x value will come from using the positive portion of this formula, -6 plus the square root of 28 over 4. The second solution will come from using the negative portion of the formula, -6 minus the square root of 28 over 4. Remember, both of these values will be answers to our original quadratic equation and x-intercepts. To simplify, we are going to start by rewriting the square root term. The square root term is divisible by a perfect square, which is 4. So we're going to rewrite the square root of 28 as the square root of 4 times the square root of 7. The square root of 4 is 2, so we can rewrite the square root of 28 as the square root of 2 times 7, which would give one answer as -6 plus 2 square root of 7 over 4. Noting that we can actually reduce this answer because all terms are divisible by 2. So dividing everything by 2, our final answer would be x equals -3 plus square root of 7 over 2. Again, note that I just divided every piece by 2 to reduce this down. This would be our first x answer. Our second x answer would be negative 6 minus 2 square root of 7. Again, just rewriting the square root of 28 as 2 square root of 7 over 4. And then reducing that one by 2. Negative 3 minus square root of 7 over 2. Now please note that there are multiple ways that these answers can be represented. You could write a final answer this way. The final answer could also be written as negative 3 plus or minus the square root of 7 over 2. This would work as a final answer. And finally, you could convert these each to decimals. If you divide negative 3 plus the square root of 7, that quantity, by 2, and negative 3 minus the square root of 7, do that first in your calculator and then divide that answer by 2, the two decimal approximations that you could get for this answer would be negative 0.17 or negative 2.8. Those are rounded versions. Now we will get more into the details of the quadratic formula tomorrow. The piece that we are going to focus on today is this piece right under the square root, b squared minus 4ac. That piece right there has a special name. It is called the discriminant. And the discriminant is a piece of the quadratic formula that tells us how many solutions our parabola will have. Will it have two solutions or x-intercepts, or will it have will it have no solutions, or will it have one solution? And the way that the discriminant tells us this is by its value. So if the value that we get, the number that we get of our discriminant is a positive number, just like here, 28 is a positive number, we're going to have two final solutions. If our discriminant, or the number under the square root, is a negative number, for example, if this were negative 28, we cannot take the square root of a negative number. It is not a real number. So therefore, we are going to have no solutions for this parabola. And if the value under the square root, once we simplify it down, if that discriminant equals 0, we will only have one solution, because when I add or subtract 0, it will not change my answer. In fact, that means that the negative b over 2a, do you recognize that, will be my vertex, and it will fall right on that x-axis, making only one solution or x-intercept, or 0. To summarize, the discriminant, you'll see this on your note sheet, is the part of the quadratic formula that is under the square root, and it can tell us how many solutions our final answer will have. If the b squared minus 4ac under the square root is positive, the equation will have two real solutions, two x-intercepts. However, if the b squared minus 4ac equals 0, the equation will have only one real solution, and it will fall someplace along the x-axis. If the b squared minus 4ac discriminant under the square root is equal to a negative number, the equation will have 0 or no real solution, because it will not cross the x-axis. Today your homework will just be working with the discriminant. Your goal will be to find the number of real solutions of each quadratic equation using the discriminant. Your first step will be to identify a, b, and c. In this first example, a is 3, b is 10, and c is 2. Then you are going to plug your values into the discriminant, which is b squared minus 4ac, this part of the quadratic equation under the square root, to determine how many solutions your equation will have. b is 10, so 10 squared minus 4 times 3 times 2. 10 squared is 100, minus 4 times 3, which is 12, and 12 times 2, which is 24. My discriminant then will be 76, which is a positive number. Because it is a positive number, it will have 2 real solutions. So my final answer will be 2 real solutions. And you'll note that if we were to continue and graph this parabola, it would cross the x-axis at 2 places. And if we were to use the quadratic formula in its entirety to solve for x, we would have 2 real x solutions. For our second example, a would equal 9, b would equal negative 6, and c would equal 1. Plugging into our discriminant, b squared minus 4ac, we have negative 6, remember put it in parentheses, minus 4 times 9 times 1. Evaluating, we have 36 minus 4 times 9 times 1, which is 36, and that would equal 0. Because the answer to our discriminant is equal to 0, the equation would have 1 real solution, and so we would say 1 real solution as our answer. Our last example, making sure that our original equation is in standard form, which it is. A is equal to 1, b is equal to 1, and c is equal to 1. Plugging that into our discriminant, b squared minus 4ac, we would have 1 squared minus 4 times 1 times 1, or 1 minus 4 times 1 times 1, which is 4, would equal negative 3. Because our discriminant is a negative number, we would have 0 real solutions, and that would be what we would write down. 0 real solutions. To finish off our lesson, let's do one more version of the quadratic formula song to get it in your head, and you will hear more of these on your next lesson. See if you can sing along with it.